Good afternoon, everybody. My name is Jamie Brill, and I am the marketing manager here at Fortress Power. Thank you all so much for joining our webinar. Today's webinar is for FAQs of lithium battery energy storage. As you know, many installers and solar experts are planning on using lithium energy storage solutions for their upcoming projects. Many of them are still facing challenges of how to sell and install them properly. During this webinar, we will cover many topics on lithium energy storage, installation, and chemistry. If you can please submit your questions towards the end, we'll make sure to answer all of them. And now I would like to introduce Jing Yu, our CEO, to begin the webinar.
Hello, everyone. I hope you guys can hear me well. If any of you have, problem with the sounds, let us know. You can type in. First of all, really thank you everyone for joining us. I hope all of you and your family are safe and well. Now, a brief introduction about myself. My name is Jing Yu. I've been actually in solar for many years. Right after graduating from school, I joined, renewable energy and just love what I'm doing. Before I worked with Fortress Power, worked for Fortress Power. I was country manager for a module manufacturer for over 10 years. And then I also got my electrical engineer degree in Germany. That was very helpful because remember, that's where the solar renewable energy started, is in Europe, especially in Germany. Okay, so let's dive into the presentation here. We're gonna really start talking about why energy storage, what it makes sense for your customers. And also gonna talk about a brief introduction about the company. Then I'm gonna focus on the battery technology comparison between different lithium batteries, how lithium's compared with other lead acids batteries. And then also gonna introduce different hybrid inverters available on the market. At the end, I will also briefly talk about how you design lithium energy storage, especially for backup applications. We have developed an Excel-based tools that can be, shared with you guys and you can use for your projects. Okay, so let's start it. Now, I'm sure a lot of you, probably all of you, are very familiar with PV grid-tied systems, right? And it has thrived in the last 10, 20 years globally. Now, with the PV systems, we're still having a few challenges. One is how you're going to balance the generation and the consumption. Because oftentimes during the day, your PV produce a lot and you're not home and you have to feed back to the grid. And second thing is that traditional PV system has shuts off when the grid goes off. So it can't really give you backup power when there's power outage. Now, also in some countries or areas, you're not allowed to feed the excessive power back to the grid. In that case, you may lose the production. That's the energy storage going to come in place to help you solve those issues. First of all, when you put energy storage systems, you can keep your system up and running when the grid goes off, because it's going to form its own off-grid systems and keep a panel and inverter, all operating, supply your home load. And then second is that now if you can also capture those excessive power during the day and for the evening, and that's a great way to improve your efficiency, system efficiency. Remember, when you feed the power back to the grid and then transmission to the transfer and stuff like that, it's all going to lose efficiency. And it's a great way also to help even the utility companies to improve their grid resilience. That's why we see more and more utilities also put investment in the battery technology or investment in building a large utility scale projects, as well as some utilities even incentivize homeowners to put energy storage in their homes to help shape the peak demand. Now, the nice thing about is that technology is always continue be improved. And that applies in the battery technology as well. If you remember 10, 20 years, 20 years ago, even 30 years ago, if you have a phone, that's very premium to have, and you have to carry, huge big bag to charge your phone. And these days, you just have your iPhone and everything you can manage from your iPhone. And that's also the same, now in order to get the same amount of usable capacity of a battery, then your battery bank will be much smaller. This is a research that Bloomberg published. Jamie, one quick, Jamie, do you mind actually unmute yourself?
Sure.
Okay, that would be great. Okay, thanks. So here, this is a chart that Bloomberg published. Shows the trend of all the markets, development in the next 20 years. As you can see, we're going to expect very nice growth across all around the world. Now, US is here is going to be really the number, the number 2 market, and then other countries, if you look India and Latin American market is also going to be a very big market. Now, this is a graphic shows that how the energy storage development in the US market. Now, the number may change now, right? Because this is, remember, this is a projection we did before this pandemic. This may change a little bit, but overall, the trend is that it's going to grow, and utilities is going to be very dominant market. Again, right, they have a large economy scale that puts like a megawatt hour systems, or even 100 megawatt hour systems here. But if you look on the residential and non-residential, there's also very nice growth here. And I know that's most of, you're going to be focused on that area. Also, let's take a look of Central Latin American market, because this is a very interesting market in the sense that you have a lot of sun and a lot of areas the grid is pretty vulnerable. And the people also very familiar with the battery backup systems there. And in this market, you can see it's also very nice growth for all the segments. If you're looking to the remote power and residential and commercial, you see, nicely annually 30% of growth. Now, what energy storage can do for you? Now, technology is already so advanced that you can have one systems, one product to cover all your needs. You just need to figure out what you want to do. You can also flexible reprogram those applications, to meet your needs. Traditional energy battery backup systems or energy storage is for off-grid application. There was the dominant, but in the last few years has changed significantly. The grid interactive energy storage is now more than 90% or even 95% market share. Majority is still used for backup because again, we are experiencing more storms as well as, some areas, countries, the infrastructure is not that great. So that's, people need that backup power. And then you see also self-supply models become also popular, where people are thinking, why should I feed the power back to the grid? I can, store them with my battery for my renewable energy, and I can use them in the evening or whenever I need it. Or you have areas, countries, or states that have time of use rate. Now you can put energy storage program, have the battery to be discharged during the peak time, and then that way you can save save your electricity cost. Now another applications become also more popular, mainly for commercial, but also for some residential home as well, is the demand reduction. So we're gonna have a slide talk more in depth about that, but basically as a commercial customer, you will be penalized because you use a lot of power, you draw a lot of amperage from the grid, and the utility will charge you certain dollar amount for that power that you draw. And they take the highest number of the months and applying, the dollar amount they want to charge you, and then some places could be very expensive. And then just have solar itself cannot avoid that peak charge. Having a battery is going to help you. We're going to go over quickly, use the graphic to explain the different systems, how it works. Now, standalone off-grid systems pretty simple, right? You have a hybrid inverter, sometimes it's also off-grid inverter, connect the solar panel. You have the battery and load. So your PV and your battery is gonna run your whole house. Oftentimes, people will also add a generator as a backup. And then this graphic shows you how systems that typically, I would say typically here in the United States, or maybe, or even also in some other countries like Europe or Asia, they do is that you can feed, you have a hybrid inverter with a battery, the whole energy storage systems hooked to the solar panel, as well as to your load. You can build, essential load, or even if you want back up your whole house, that's also doable. It's expensive, but it's doable. And your systems also connect to the grid. So when you have excessive power during the day, the PV is gonna power your load, charge your battery, and then any excessive power is gonna be feedback to the grid. And if cloudy days and the inverter can also take the power from the grid to charge the battery as well. Now, the priority for the electricity flows always power the home load first and charge the battery, and then send it back to the power. So that's how they're going to prioritize the power flow. You can also add a generator if you want. And in this case, if the grid goes off, if this here got disconnected, then the system will act like an off-grid systems, just like the one I showed you before. More and more areas are now, there are, for whatever reasons, maybe because electricity cost, maybe because you can't feed the power back to the grid, because just like Hawaii, the infrastructure is weak, so you can't have all this power at the same time sent back to the grid. Now, the utilities encourage the home owners or the facility owners to put a self-supply systems there. So in these cases, you can see you are not feeding any power back to grid, but you can take power from the grid if you need it. Now, let's see how the system works. In the morning, sun shines, your PV start producing power. It's gonna power your load, charge your battery, and usually by the end of the day, the battery will be fully charged, sometimes even quicker. And then in the evening, you will discharge your battery power to supply power to your load. Now, maybe sometimes, in the summer, you have your air conditioning on and you need more power, you can take in the middle of night. It can also take some power from the grid to supply it. And next day, you're going to do another round again. So this is, we've seen very, more and more popular, like in Hawaii, Arizona, and of course in Central Caribbean or even South America, as well as in Africa market as well. The time of use is really for areas, like I mentioned, that you have on off-peak rates. Typical example is California, that the peak period somewhere between 4 to 9 can be expensive as 50-60 cents per kilowatt hour, and off-peak could be only like 16 or 17 cents. So in that cases, you can program in your systems, have the battery to be discharged between 4 to 9 p.m. and then to lower your electricity cost. It can also work without solar, but of course, if you have a solar, you're going to get a clean energy. And also, like in the United States, you get 26% of ITC on your energy storage if it's hooked up to a solar and powered by solar. Demand curtailment, this is one that I mentioned earlier, that if you are commercial customers, or I know that our residential customers in Arizona also gets paid pay their demand charge. Now that's the KW charge. If you look on your electrical bill, Here, for example, let's take New York as example. In New York City, in the summer, they're going to charge you a demand charge for businesses, can be as high as $35 per kW. And oftentimes you look at a customer's electrical bill, more than 50% is the kW charge. And that is, like I mentioned earlier, just when it happened one time. For instance, if an office building, usually you only need 100 kW, but for whatever reason, then one day you need 200 kW. If it happened once, they're going to charge you 200 kW multiply $35, for example. And then just by PV itself, can you lower your consumption, but not the kW charge? If you add in a battery systems, energy storage system to it, what it does is it will frequently measure your consumption. And once you sense if you want to go above, let's say 100 kW, that's maximum you want to have. Once it go above the 100 kW, the energy storage system will start functioning and lower your kW to make sure it's within that target line you want to achieve. And we also working on a separate webinar. It's going to come up in a few weeks. Just talk about a commercial energy storage, how it works, what component you need, and what's the financial return on that. So stay fine-tuned. Fortress Power, we are a lithium battery manufacturer. We focus on lithium ferrophosphate technology. It was primarily used in the automotive, and of course we customize it and bought that technology for the energy storage application. We're based in Southampton, Pennsylvania. We are in a do R&D, sales, support and logistics support from our headquarters. Here, as you can see, we have also solar panels powered by solar panels, of course, backed up by Fortress Energy Storage. We also have logistics centers in California and Florida to serve the customers in the West Coast, Hawaii, as well as, in the South and Central Latin American market. We have a 45 megawatt installed worldwide in different capacity, smallest the system 5 kW and go to a few hundred kilowatt hour systems. Also very proud to be the exclusive battery supplying for the local transportation company, because again, this is a high safety applications, and we are been there for supplying the power stations, the gear control systems for 2-3 years now. We have our products made in China, in Shenzhen. If any of you been there, this is a Silicon Valley in the east. A lot of smart engineers. It's also a manufacturing hub for power electronics and lithium batteries. And those are the two very important components for lithium batteries. Also, I want to always bring the fact to you that the lithium ferrophosphate technology that we focus on, it's a proven product. It has been used for over 10 years, primarily in automotive. Now the lithium ion technology that we're going to compare later, that Tesla, LG Chem, and Panasonic, they focus on that technology. Those are really gaining that attraction in the last 3 or 4 years. So they still have a way to go to prove themselves for the safety aspect as well as for the longevity aspect. Here, the 3 products line we offer. eVolt, it's the flagship product, mainly for home and also for businesses as well, because you can stack them to up to 12, get 222 kilowatt hour, hook up to this one inverter. And the smaller units we offer is the 10 and the 5. The 10 and 5 we've seen is more popular for cabinet solution, as well as for outside the U.S. market, like a Central Latin American market, Africa. Those are countries or people, homes that they're satisfied with a 5 kilowatt hour or 10 kilowatt hour. We're also going to launch a new product called eFlex 5.4. It's a very nice product. It's making them smarter. You can do closed loop communication with the inverters. Also, It has memory card for storage, the data storage, so we can go back to track, see how the battery is being used, and also it has built-in Wi-Fi remote monitoring. Now you can monitor the battery from anywhere. It will come with also a phone app as well, and that really is the purpose of investing also money in the monitoring, is we want to help you to monitor the batteries, you and your customers. And if there's any issue, it will give you error message. This is just more productive, and make sure that your customers have the best user experience with the lithium batteries. It's also designed to be installed. You can wall mount it, or you can stand on the floor if you want it. Of course, it can also fit to a standard computer server rack. We actually also going to come up with the Fortress enclosure as well, with a built-in bus bars. So if you need to pair multiple units and bus bars already built in, it makes installation very easy. Here are the technical specification. I'm not going to go through one by one. A few bullet points is here that it is a 48 volts battery. Now we do offer 24 volts battery as well. And if any of you are interested, we do offer, but again, that's not the main product line we offer, but we do have customers in the market looking for 24 volts. That's why we developed for them. Now, lithium battery, different than traditional lead acid battery, is that it has battery management systems, and there are power electronics. So when you design the systems, you have to make sure that the inverter you're going to pair with that matches to the maximum charge and discharging power that the battery management system allow you to do it. We do have a detailed section, webinar section called how to design and install lithium battery in general. That's a section we're going to have, I believe, sometime next week, if not a week after. If any of you are interested, please join that webinar. We're going to work with you through step-by-step how to design the systems. The eVolt, you can stack 12. The eFlex is 15 units. The 10, the 5, 2, and 3. And I'm going to explain why we designed that differently. It's really based on the battery management system that we use. The eVolt has a local monitoring. Also, the eVolt eFlex can communicate. So it can communicate with inverter. It can communicate between the batteries. That's why we, feel more confident that you stack that units more. And with the 5 and 10, that is no communication. So you will just set up the parameters in inverters. So we just want you to go with the 2 or 3 of them. And I know there's also manufacturer without any communication. They also let you stack many, like 30 units. Frankly speaking, I don't know if that's, that's a good idea, but we want to be conservative. It all has breaker. We do have the warranty of 5 or 10 years warranty. Depends where you are, and also depends, if you want 10 years warranty. Here in the US, Canada is 10 years, and some other countries we offer 5 years with lower price tag. And if your clients want to extend it, it's at a very minimum cost. You can extend it to 10 years. In both cases, we offer 6,000 cycles. Now, we're going to dive into talk about the different battery management systems and also different shape of the battery cells. Now, on the market for the lithium battery, in general, there's 2 different battery management systems. One's called a MOSFET based, another's contact based, or called a relay based. So use, solid state relay, for example. The difference is really that the contact based, the BMSs are in the terms can handle more larger charging discharging rates. And if you need for big systems, the contact based is much better. It provides, longevity, and also it's more robust. But if you do a smaller systems, the 5 and 10 works well. They all will protect the cell from overcharging or over discharging, protect them, from the overheat and low temperature. It has also, overcurrent protection, like the breaker and the fuse, as well as, protect if there's any short circuits or open circuits. The BMS will also disconnect and then make sure that inverters, will not overpower the battery cells. The 5 or 10, we use the cylindrical. This is similar like AA batteries. They're smaller, so they're flexible to be assembling together. You can design them, more flexibly. The EVO and eFlex, we use prismatic. The prismatic cell are rectangular shape, and again, those are also proved to be more efficient, as well as, if you need that many cycles, the prismatic cells also can offer you more cycles. Again, for the eVolt eFlex, it's redesigned for big systems. That's why we choose, solid state relay, as well as the prismatic cell to build, more robust for your applications. The eVolt 18.5 has a local monitoring. You might have clients that are not very technical savvy, and they would like to have a local monitoring. And this is going to show you the voltage, the state of charge, charging, discharging current. It also has the error message code here. For instance, if the battery is, overcharged and the voltage goes too high, then that circle is going to turn to red, give you, error message, and then you know what's, how to handle that. Okay, we're going to stop here. And Jamie, do you mind actually to pop up the questions? Okay, so we have a poll question just asking, people trying to know how many of you have installed lead-acid system before, and how many of you installed the lithium systems. Let me see how can we look up the.
So if you go to the polls where it says polls, you can see people answering right now.
Okay, good. Okay, I see people are answering very good. The numbers going up. Let's give a few more seconds. And I appreciate you guys participate in the survey here. I believe now we have almost the number collect here. Mm-hmm. We have 9% people actually install lead assets. 10% people install the lithium batteries. And then we have also 23% actually did both, so which is, that's great. And then there's 28% people that I haven't, installed it before, but I'm sure, now it's the time, right? Good. Thank you for your participation. That gives us good ideas, that how you're familiar with the different batteries. Now there are many different lithium battery chemistries available on the market, and I've been always follow up with the new news about new technology. There's more and more going to come up, and a lot of them are under lab test. Why did it commercialize as 3? Let's start with the lithium ferrophosphate or lithium iron phosphate. Sometimes you also can call it LP or LiFePO. They all talk about the same chemistry. So when you read them, don't get confused. It's all the same chemistry. And then you have another chemistry that now also very popular is the nickel manganese cobalt, so NMC. You can also call the lithium ion batteries. And then we also seen some consumer products, most likely in consumer products, but there's also a manufacturer that use that polymer as well, so call it LiPo to the 100%, and that's a good way to retain those cycles you can get out of the batteries. Now, again, globally now, if you look on the statistics, like last year, over 90% energy storage are installed with a lithium, and that's a reason for that. Of course, we know lithium is popular, lithium's advanced technology. It is more expensive, and it gives you more cycles, more energy throughput. And if you take that in consideration, the actual energy cost is much lower than the traditional lead acid batteries. Now here's the graphic. We made a comparison here. We will start about round trip efficiency because we're in renewable energy. Now the renewable energies, it is still expensive, compared to fossil fuel. So the better efficiency you can get, it's always, a better economics you can get. The LFP has 98% round trip efficiency. The other lithium batteries about 95%. The flooded lead acids 80, AGM's 88%. Nickel iron is much less, it's only 65%. And we did studies at each battery, we let them discharge at 80%, and that's the cycles for the different chemistries. The off-grid years that if you do one cycle a day, how long the battery can last, it varies from, with LFP, you talk about 16 years. The other ones about 7 years. Flooded lead acids, AGM, it's much less if you do 80% double discharge. But typically people use at 50% double discharge. But again, we just want to be on the same apple-to-apple comparison. That's why we did this way. And if you look at nickel iron, it's very good. They do have a lot of cycles. Now, the really important term is energy throughput. And what is an energy throughput is the total amount of energy a battery can be expected to store and deliver over its lifespans. And how does this number come? You use your nominal capacity. In this case, it's a 10 kilowatt-hour battery bank. You multiply 80% of double discharge, because again, we not discharge a battery in full, we only does 80% in this study. And the efficiency is 98%, there's 2% power loss, and multiplying the cycle lives, the 6,000 cycle lives that we guarantee. Now, of course, if you use the battery, carefully, you can get more cycles, but this is, based on the warranty that we offer. You can get 47 megawatt hour from the LFP10 lithium ion, about, the half polymer is only 1/4, and flooded AGM, or flooded lead acids AGM are much less. The nickel iron is pretty good, it's the number 2. Again, because it does have a lot of good cycles. The disadvantage is the efficiency and the cost here. Now, let's take retail cost here. That again, this number varies in different countries because some countries there are import tariffs and fees on top of that, so the price can be higher. Use the out-of-pocket cost for a homeowner as an example. And to divide the energy throughput, now you can get 14 cents per kilowatt hour on the battery side. Of course, you need to also calculate power electronic cost. Depends what inverters you use. And the lithium ion, lithium polymer, more. And look, the AGM families are much more. You talk about, 4 or 5 times more than the LFP chemistry, or more than the lithium chemistry. That's why now you see more and more investment in the lithium energy storage instead of lead acids. The nickel iron is pretty good too, but again, it's expensive, need a lot of space, so it's more popular for big projects, like utility. They like to use this chemistry, or they like to use these chemistries before, but now they're also shifting to the lithium as well. Okay, and in terms of the safety, LFP and nickel iron are very safe. The other ones, either you have the temperature, sensitive element, or you can release harmful gas with lead acid batteries. In terms of the maintenance, now the flooded lead acids and nickel iron, that you do need to go back to, maintain the batteries, while the other ones are free maintenance, and that's also much less headache for the homeowners. So we explain economics. Here's also a graphic to show you that that happens a lot, especially if you are in the south and you need to have your air conditioning run on. Here is when you use the lead acids families, when you start to draw that power, especially turn on, air conditioning, and the capacity will drop very quickly. So a battery which is supposed to last for 2 hours, if you just use normally and you turn it on, your AC, and offset, certain minutes later, the system shuts off. With the lithium, you don't have that concern as long as it's within the BMS threshold, like maximum discharging rate. You can expect the battery gonna last as 2 hours. It will not, die earlier, and that's also nice, more predictable. And plus, we talk about LFP capacity is your actual name capacity. So for 360 amp hour, you can really get 360 amp hour out of it. With the lead assets, usually is 50%. So when you do a cost calculation, you have to consider that differences. If you want the lead assets for 400 amp hour, if you want to go with the lithium, you probably need 200 amp hour, maybe 2040 amp hour at 80% double discharge, as example. Here, just a graphic shows you. On the left is AGM batteries, 2050 amp hour, 6 kWh usable power. This is the EVO, 360 amp hour and 18.5 usable power if you want fully discharge the batteries. A quick summary. The technology advantages that the LFP chemistry offer: safe, you get a high energy throughput, and you get long durations. We talk about 15, 16 years, and you get the lowest energy cost. So if you need that many cycles, it really makes sense with the LFP chemistries. Okay, we're going to talk about how you integrate the battery to your PV systems. Those are two different ways of doing that. One's called AC coupled systems. It's I'm sure a lot of you, if you're based in the United States, you're very familiar with that. Basically, you have already PV inverters, existing PV inverters. It could be string inverters. It could be, microinverters. It could be also a solar age inverter, right? Optimizer plus the string inverters. And then you just hook up your energy storage to existing inverters. The battery is going to be charged through the hybrid inverter. So you're going to through the AC power, either the AC power from the panels or the AC power from the grid. So if you look into the systems, you can see there is more efficiency loss in the sense that because your panels from DC convert to the AC, goes through 2 inverters and then charge the battery, convert back to the DC. So you have a multiple conversion, and plus that the PV inverter, any hybrid inverter, they all need to all meet the rule, the so-called sound specs, standard rule 21, make sure that both can communicate with each other through the frequency shift. But even though there's still a problem if in off-grid applications, when in the means if the grid goes off, plenty of sun, you're not using a lot of power. In that cases, your battery is fully charged, then the hybrid inverter's frequency is going to go up and shuts the PV inverter off. And then you wait for 5 minutes, the inverter come back again, shuts off, and that's a kind of annoying. So personally, I really prefer more DC coupled systems. So if possible, I would do DC coupled system. Then you don't need a PV inverter. You have instead you have a charge controller. It could be separate units. It could be built in one, with the inverter together in one box. The panels gonna go through a charge controller, step down the voltage and then charge the batteries. And the battery can also be charged by the inverter, take power from the grid as well. It's more efficient. You don't need the additional PV inverter. And also you do not have the issue I described before, because that the hybrid inverter can regulate the PV productions. So you don't have that overpower, with AC coupled systems during off-grid time. Here are a list of inverters that we work with. Some offer both AC DC couple, some's only AC couple like SMA and Victral. The other charge controller, Morningstar, Midnite, those are DC couple systems. If you are plan to use our batteries, we need other inverters not on that list. Don't worry, just send us an email, and at the end of the slides, I'm going to show you we have a tech support email address you can send in, and then our engineers will verify that. We are working with the 3 companies here on integration. And I know in the Schneider, actually, it's already completed. Now we're going to go to the beta testing. And SOARC is getting very close. SMA is going to be the next one. And Victros is also the one that we are going to do after we finish up the other three. I'm going to actually introduce quickly about the two different hybrid inverter on the market. I'm sure a lot of you are familiar with the Schneider. They've been on the market for 10 years. It's system designed very flexibly. You can, add as many charge controller, depends on your PV array, or you can stack inverters, depends on how much power you need to, how big of a load you have. It supports both single and three-phase. It covers almost all applications we talked about earlier. Now you can do DC and AC coupling. If you do DC couple, you have the charge controller. If you do AC coupling, you just, remove the charge controller and AC couple to your existing PV inverters. Has a great hot environment performance. We're working with them on this real wheel project here in Pennsylvania, and the reason they choose the Schneider is because the excellent environment. They have a very big environment span from somewhere between actually I think the -4 Fahrenheit to or -25 degrees to 70 degrees Celsius. Some technical specification here. These days, it's very important when you look at an inverter, you're looking now for the AC output, AC output in full capacity, and then also look on their surge capacity as well, because you need that to design how big critical load panel you have or essential panel you wanted, as well as to based on your inverter and based on your load panel to design the battery banks as well. Again, we're going to talk about that in this design and installation webinar. It has built-in transfer relay, so if you do not need a separate transfer switch, but if you do big systems like 3 or more stack of them, you might need external transfer switch. But if you do 1 or 2 units, it's not necessary. Those are inverters. It can AC couple to it. Like I mentioned, you can do single or three-phase. In three-phase, you have 3 legs, and each leg you put either 1 inverter, or each leg put 2 or 3, for your 208 systems. Now, there's another new inverters on the market is that there's charge control already built in. It's easy installation, but of course, you do not have that flexibility. It says, okay, I want flexible charge configure charge controller, and hybrid inverter depends on the PV array or a load panel size. But it's makes installation easy. We actually group them together, offers a turnkey solution for our partners. The nice thing about this turnkey solution that we provide is, a few things. Either install, we talk about it. The other thing is that you can also do stacking in single and three-phase, the same way you do with the Schneider equipment. It has very high round trip efficiency, 93% from PV to the battery and to the load, and that's amazing efficiency for energy storage systems. It comes with a auto gen start. If the battery goes to a certain level and there's no solar, the generator will turn on to power the home. You can do AC, DC with the same unit, and it covers all the applications you need it. Here are the specs. Winds on the solar battery, it's 8K. Winds with a generator, with an AC grid can go up to 9.6 kW to a critical load panel. It can also pass through 12 kW to the grid. That's why you can hook up an array 13 kW in optimal south orientation. If you have, north, east, or west roof, then you can add more PV to it. And that's nice because you have a once inverter can handle a big array. It also has a built-in transfer relay and has an amazing surge capacity. You can see 20 kW 5 seconds. The Schneider has also very nice surge, 12 kW for 60 seconds. It's very nice surge capacity as well. And that's very important when you choose the hybrid inverter that has surge capacity, because otherwise for example, just give you example, Tesla Powerwall, it's a 5 kW inverter and only can surge 7.5 kW. So it's only 33 amps. It's very small. Here's in DC coupled systems, show you the wiring to explain. You have solar comes in to 2 MPPTs. So each MPPT has 2 strings. And then you have the battery here, while charge controller sits here. The PV comes in, charge the battery. And then you have a load, essential load panel, the 50 amps essential load panel, connect to it. And then you can have a grid, connect to the grid, to the main panel and then to the grid. You can use the generator as an option to hook up to a generator. So it's really easy. If you do AC coupling, then you will hook up your AC, your solar panel, your PV inverter to the same essential load panel. Now, there's one limitations. In this cases, you can't use generator anymore. So the generator input, that is, you can't use it at that point. That's the limitation. So if you need the string level rapid shutdown, it works with the Midnite rapid shutdown devices. You have the transmission receiver. Either you give a signal on the inverter here or on the rapid shutdown button, then the transmitter is going to send a signal to the receiver and the strings will disconnect. If you need a module level rapid shutdown, which I know that now most of the the states here are require NEC 2017 code, then you can use the Tigo rapid shutdown equipment and put in the back of each solar panels, and the same you can initiate use the rapid shutdown or even like remotely disconnect the systems, disconnect the rapid shutdown devices for safety. Okay, we are almost at the end. It's going to just be very quickly talk about how you size up a battery backup systems. I'm sure most of you are very familiar how to size the PV systems, and this is just an add-on to that piece. Is when you design, especially the backup systems, the first thing you want to do is you want to select the loads to be moved from main panel to the backup panel. We have Excel going to show you, help you to go through those possible, circuits you have. And then based on what you selected, you can calculate your daily usage of the backup load panel. And then third steps, you're going to based on the days of autonomy the customer want to achieve and plus customer's budget to select the battery bank size. At the end, we also recommend you do a production estimate to estimation and explain the homeowner or your facility owner how the PV systems, what they can expect in different months from the PV plus storage. Okay, now this is Excel based. Like I mentioned, we categorize the circuits or home appliance by essential, kitchen, personal appliance, HVAC, heavy duty equipment. So you can go over that category with your customers and select their items they want to be powered during the power outage. Put a quantity, the starting wattage and running wattage is already built in. So that saves a lot of time. You don't have to go look at each equipment and figure that out. And then you put in the operating hours per day. Some of the appliances that we already have built in suggested hours of operation. For instance, if it's Energy Star rated refrigerator and freezer, it's 8 hours because the compressor will turn on off, so it's really 8 hours. Now it's going to give you an idea for that appliance that you selected, how much electricity it's going to consume in 24 hours. So here's the the 12 appliance that homeowner wants to power, and typically there are refrigerator, lights, sump pump, water pump, your kitchen outlet. You also want to be able to watching TV, charge your phone, and then if you have more, You can also put, small window AC units and furnace systems as well. So this particular house that it needs about 9,600 starting wattage, right? Again, this is assumed everything turns on at the same times. Could that happen? Yes, but likelihood is very low. And then also the running voltage, when you have everything on, it needs 6,800 watts, 6.8 kilowatts. Total consumption is around, close to 18 kilowatt hour. Now with the SOAC 8K inverter, in this case, the customers choose to go with the SOAC 8K. You can see that it's within the inverter surge capacity, as well as, also within the running capacity as well, the running wattage. You can actually put a little bit more if you like. So if the numbers you choose, if the circuits you choose are over the inverter's threshold, then it will turn to red, just give you a warning. Is that critical? Maybe, maybe not, because if you go over a little bit, doesn't matter, because, like I mentioned, you're not going to turn on everything at once. And then this system's based in North Carolina. We also did, AC energy analysis by months. So for this particular systems, that it's going to produce about, each month it's different. And we're going to focus on June, is close to 37 kilowatt hour. December is about, 21 kilowatt hour. Now, in June, that means you have plenty of the power. You can charge your battery. If your battery is, fully discharged the night before, you still got another 18 some kilowatt hour you can use during the day. And if you don't use it, of course, getting the loss. So you can, it's encourage you to use them. In December, then if you want to be cautious because you want to have the PV production to charge the battery first, and you can use them in the evening, and then whatever left over you use during the day. So it's a good way to actually explain the homeowner how they're going to handle their consumption behavior. Now, typically we suggest that you start with a 1 day of autonomy. So in this case, it's 2 of the 10 works well, because the 2 of the 10 can give you 1 day autonomy, and then you expect it, the solar's come producing electricity to power the home. But again, if your clients wants more than wants, 2 or 3 days autonomy, you can certainly do that. For other applications, due to time, we are not going to talk about them. And like I mentioned, we're going to have a section talk about demand curtailment in the next few weeks. That's more for commercial customers. And if you need any help to design the systems, you can contact us, sales team, and they will give you a very simple project sheets, very simple, take a few minutes to fill out, and our engineering can, design a system and put a BOM list for you. Okay, so we are, we want to work with more installer and distributors globally. So you can, there's a dealer form you can download from a website we can send you, can fill it out. For some areas, we would like you to go to our distribution partner, because we do have distribution partners that are very good. They can give you technical support and stock the products. But for some areas, if you do not have a distribution partner, then, we will serve you and as installer. But again, our goals, we really want to partner up, with the people that are, can be well trained and install the systems properly and make sure that the customers, the end users are happy. So once you fill out that form, we can put you on the product and sales training. And then next is design installation training. That's the design and install training that I'm talking about. Here's my contact information. Also, if you're any, fill out the form. If you have a question about, projects, and you want to get quotes, you can contact sales@fortunespower.com. And if you need a technical support or a tech support email, you can send it. And if any of you, maybe you're existing partners in this webinar, or you want to do some co-marketing, or you can contact Jamie directly as well. that's my presentation. I really appreciate that. Now we're gonna put out the questions here.
Yes, we have a couple of questions. Let's start at the beginning. We have a question about distribution channels in Nigeria. Do we have any, and are we able to sell directly to the end user in Nigeria?
Well, for Nigeria, we do have actually, we have, I know we ship the product there. We have distribution partner for those countries, and I will really encourage go through distribution partner because they really know how to handle the shipment. It makes life for you, for us, much easier. And we can send you that, contact, distribution contact.
Yeah, just reach out to us at sales@fortresspower.com and we'll send it to you.
Yeah.
Okay, the next question is, which programmer do you recommend to control the energy flow from the inverter, PV modules, battery to the load grid?
The inverter do it. Like the inverter, the list of the compatible inverter I show you. Besides, if it's charge controller problem doesn't do but the top, few of them, they all can do the same. They can already manage the electricity flow. Depends on what application you're looking for. But
Okay.
There's one comment, if you do the demand curtailment, like I talk about, reduce a kW charge, then you will need additional energy management systems. And then we are going to offer an energy management systems for that.
Okay. Arturo is asking, in commercial applications, three-phase systems are amply popular here. Do you need 3 inverters or do you know of a three-phase built-in device?
Very good question. Currently, the inverters that I introduced, there are you put each one, 3 in each phase. You put 1, 2, or 3, whatever the unit is, to build a 3-phase. But there's also one single inverter can do 3-phase. That's something that we are actually, was talking to a few manufacturers, looking to get one that we can partner up to do that kind of system. It will make the installation easier and, of course, also less cost.
Okay. Can you monitor the battery now?
Now, it's in a work in progress.
Okay. Max size of battery, we have projects that require 2 megawatt hours for 2 hours.
Mm-hmm.
Is it a local rural electric co-op?
Oh, okay. And where's it? I don't know where it's based. For that type of systems, at this point, we cannot offer. But like I mentioned, we are want to integrate, a big inverters, and that would be a container solution, maybe in the future, but not right now.
Okay. The next question is, what is the DOD of the batteries?
You can do 100% double discharge, but we recommend you do either 90% for 3,000 cycles or 80% for 6,000 cycles. Depends on how many cycles you need.
Okay. Juan is asking, in the LFP 5 and 10 batteries, when you say the cell type is cylindrical, are they 18650 cells?
No, we are big ones. We are the 3, don't count me, I forgot the numbers, but we are the 32650. Bigger than the 18650. 18650, Tesla use that, it's a much smaller. We use a bigger.
Okay. Carlos is asking, are the safety restrictions for air transport the same for both LiFePO 4 and lithium ion?
They are the same. For the tariff code here, lithium ferrophosphate or LFP chemistry is also categorized under lithium ion. So they just put the lithium ion for all the lithium batteries, pretty much. So you will have the same, same requirements, documentations, yeah.
Asking, Abraham is asking, do we have distribution in Mexico?
I know we are, that I have to, direct you with our sales manager for Latin American market, but I know we are talking to a few of them, yeah.
Okay. Please talk about PV curtailment in an AC coupled system when the battery is fully charged. The grid is disconnected and the PV generation is greater than the load.
Okay, so sure. I mean that's the one that I'm trying to explain, but maybe I didn't explain it so good. Is that in AC coupled system, the grid goes off, your battery is fully charged, right? And then let's example, your PVs produce 5 kW, and your load is only needs 2 kW. Now you have a 3 kW over. In that cases, the hybrid inverters, the frequency going to go up very quickly from 60 hertz, go up to maybe 60.1, 60.2, and eventually to 6.5 or even higher. In that cases, the hybrid inverter is going to send a signal to the PV inverter, tell the PV inverter to turn off, because there's no way there's no way they can absorb the other 3 kW, the overproduction. So the PV inverter has to shut off, and then 5 minutes later come back, shuts off. That's the scenario I describe. It's annoying, and so far I don't think there's any hybrid inverter on the market can solve that issue yet. So I hope I explained your question.
Okay, next question is, can we export energy from the battery to the grid?
Yes, that's actually really depends on the local utility if they allowed you to do that. If they allow you to do that, it can be set up to do that. But I know that a lot of utilities will not allow you to feed the PV power back to the grid. Oh no, not PV, the battery power back to the grid.
The next question is from Ron. What is the battery life if it is only used for power outages 10 times a year?
But then you can really go, 15, 16 years, not an issue. The battery cell can last very long. Remember, even after, 15, 16 years, 6,000 cycles, we still guarantee minimum 70%. It's more about a battery management system. Those are power electronics. I know there's also manufacturer claim that can last for 30 years. But again, we will see if the power electronics, the BMS, can last for 30 years. That need to be proved.
Okay. Marcos is asking, do we have authorized dealer in Dominican Republic, the Caribbean? If so, is it possible for our company to also become a dealer?
We do have distribution partners there. We can talk one-to-one. Depends on, are you a distributor? Are you an installer? If you're an installer, we will encourage you to go through our distribution partner because they stock product, they have engineering staff. And if you are a distributor, you resell to other installers, we can certainly, connect you with our sales manager, Mario, and then he can, help you walk you through the process.
Okay. Do your battery work with grow-watt inverter?
As long as it's 48 volts, I believe so. That's something, we need to verify it. If you can send us to the tech support, the model and the specs of the grow-watt inverter you use, we can double check and confirm that.
Okay, the next question is, does Fortress Power have representation partners in Western Canada?
In the West Canada, that's a good question, we have so many customers, I don't have them top of my head. I know we do have distributors in Canada, but in the West Canada, I need to double check that. And
okay.
what's the name? Jimmy, can you repeat name?
Sure, it's Farhad.
Okay, got you. Yeah, Farhad, we can get back to you about that.
Okay. Paul is asking, what UL certifications does the different Fortress battery models have? UL 1973, 9540, or 9540A?
So there's a few different certification. The 1642 is on the cell level, and there's 9073, it's on a module level, like whole battery bank. And then also now is there's also UN 9540 is inverter and battery together. If you are a manufacturer, you group inverter battery in one, either in one enclosure or on the same brand, you need a 9540. And then if you want to install the systems in certain area like New York City, for example, they also ask you a 9548. So you will do a, you know, smoke and salt water test. So we have the 906042 and 9073, but not the 9540. We are going to partner up with some inverter to do that test in the second half of the year.
Okay, and I believe we have a last question from Mark. Is the eVolt with a Schneider context approved for SGIP rebates?
Not with the Schneider. We haven't started the process, but with the SolarArc, the 8K inverter without eVolt 18.5, they are approved for S-chip rebates. So again, you know, California is a very different market. There's a lot of regulations, of course, a lot of incentives. So we need to work on the Schneider combination.
Okay, there were a couple questions that I skipped over just because they were asking the same question that you've already answered about whether we have dealers or do we have any distribution channels in Latin America. Just so you guys would know, if you follow us on social media, we just posted, we have a new sales manager. His name is Mario Castillo. All of his information is on either YouTube or Instagram or Twitter and LinkedIn. So he actually speaks Spanish. We do have a Spanish speaking person now. So if you guys are more comfortable speaking Spanish, you can always contact him and he can answer any of your questions.
Yeah, great. Good. Thank you so much, everyone. And, you know, we wish, you know, stay safe, everything goes well. And let's all, you know, good things. We're in the renewable energy space. We are truly to help the earth to get, you know, better, more clean for our next generation. And let's keep up with our great work we're doing.
Yes. Thank you, Jing. And this presentation and this webinar will be available on YouTube later today on the Fortress Power channel. So you guys can always have access to this exact presentation. All right.
Thank you, everyone. Take care.
Thank you for joining us. Bye-bye.
Bye.